उम्, स्वागत छ सबैजनालाई। आज हामी बिसिए को थर्ड सेमेस्टरको फोर्थ सेमेस्टरको हामी कुराहरू हेर्नेछौँ। हामी फोर्थ सेमेस्टरमा जान्छौँ। फोर्थ सेमेस्टरको हामी सफ्टवेयर इन्जिनियरिङको नोट हेर्नेछौँ। सफ्टवेयर इन्जिनियरिङ रहेको छ। सुरुमा हामी हेर्छौँ सफ्टवेयर इन्जिनियरिङ लेयर्ड टेक्नोलोजी। Software engineering is a layer technology as referred in figure shown below. It consists of four layer: a quality focus, method, tools, process. A quality focus, the bedrock that support software engineering is a quality focus. Software engineering approach must rest on the organizational commitment to quality, total quality management philosophy that support continuous improvement culture lead to the development increasingly more approaches of software engineering. Process layer, it is the foundation of software engineering that defines a framework for a set of KPA, key process area that must be established for effective delivery of software engineering technology. The KPA form the basis of management control of the software product. A project to and establish the context in which technical method are applied, work product model, document, data, report form, etc. are produced, milestone are established, quality is ensured, and the change is properly managed. Method, it provides the technical how to for the building a software. A method encompasses a broad area of attack that include the requirement analysis, design, program construction, testing, and support. A method rely on the set of basic principles that govern each area of the technology and include a modeling activity and other destructive technique tools to provide the automated, semi-automated support for process and method, integrated tools to establish computer-aided software engineering case combined software, hardware and software engineering database to create a software engineering environment analogous to CAD, CAE, computer-aided design engineering for the hardware, tools, method, process, quality focus, software process are the roadmap of building the high quality software product. रोडम्याप भनेको एउटा विचाराधीन विचार गरेर बनाएको अ, कुरा जस्तै म भविष्यमा यो गर्छु भनेर बनाउनु खोजिएकोलाई रोडम्याप भनिन्छ। द रोडम्याप टु बिल्ड हाई क्वालिटी सफ्टवेयर प्रोडक्ट इज द सफ्टवेयर प्रोसेस. Software processes are adapted to meet the need of the software engineer and the manager as they undertake the development of software product. The software process provide a framework for managing activity that can vary easily get out of the control. A different project require different software processes. The software engineer work product program documentation data are produced as consequences of the activity defined by the software process. The best indicator of how well a software process has worked are equality, timeliness, and the long-term viability of the resulting the software product. A structured set of activity whose goal is the development or the evolution of the software. Generic activity in all software processes are specification what the system should do and its development, constant design development, production of the software system, validation checking the software is what the customer want, evolution changing the software in response to changing demand, framework activities, set tasks, milestone, a deliverable, SQA point, umbrella activity. A common process framework is established by defining a small number of framework activity that are applicable to all the software project regardless of their size and complexity. The number of tasks in set includes software engineering work tasks, project milestone work, product quality assurance point. This task set enable the framework activity to be adapted to the characteristic of the software project and the requirement of the project team. SEICMM capability maturity model. To determine an organizational current state of process maturity, the SCI uses assessment the receipt in the 5-point grading scheme to determine compliance with the CMM capability maturity model. SCI approach provides the measures of the global effectiveness of the company software engineering practice and establish the five courses maturity level. CMM defines key activity required at the different level of the process maturity. Initial aid, hack, and occasionally even the chaotic software process. Few processes are defined and success depend on the individual effort. Repeatable, able to repeat the earlier successes. Establish the basic project management to track cost, schedule and functionality. Define management and engineering process documented, standardized and integrated into the organization-wide software process. Manage the software process and product are quantitatively understood and controlled using the detailed measures. Optimizing continuous process improvement is enabled by the quantitative feedback from the process and testing innovative idea and technology. Each maturity level is associated with the KPA. KPA describe those software engineering function example. Software project planning requirement management that must be present to satisfy good practice at a particular level. A goal, the overall objective that the KPA must achieve. Commitment requirement that must meet the achieve goal. Ability those things organizationally and technically to meet the commitment. Specific tasks required to achieve the KPA function. Monitoring manner in which the activity are monitored. A verification manner in which the proper practice of KPA can be verified. Process maturity level 2 software configuration management, software quality assurance, contract management, software project planning, requirement management. Process maturity level 3 peer review, intergroup coordination, software product engineering, integrated software management training program. Organization process definition, organization process focus, process maturity level full for software maturity management, quality management, quantitative process management, process maturity level 5, process change management, technology change management, defect prevention, software process model software process model or the software engineering paradigm is a development strategy that encompasses the process method and the tool layer. The software process model is an abstract representation of the process. It represents a description of a process from some particular perspective. All the software development process can be categorized as the problem solving loop, as shown in the figure, that consists of four distinct states such as status quo represent the current state of affair. Problem definition identify the specific problem to be solved. Technical development solve the problem through the application of some technology. Solution integration deliver the result. Example document program data new business function new product. Problem definition, technical development, solution integration, status quo, types of process model. A process model is chosen based on the nature of the project and application. The method tool being used and the control deliverable are required. Following types of process model are being used. Linear sequential model, old fascinated but reasonable approach when the requirement are well understood, separate the distinct phase of specification and the development. Prototyping model good first step when the customer has a legitimate need but it clueless about the details. Developer need to resist pressure to extend the raw prototype into the production product. A rapid application development, a RAD model make a heavy use of a reusable software component with an extremely short development cycle. Evolutionary software model, incremental model, deliver a software in a smaller but usable pieces. Yeah, it's a piece built on the piece already delivered. Its spiral model couples irritative nature of prototyping with the control and the systematic aspect of the linear sequential model component based development. Spiral model variation in which application are built from package software component called the classes. A linear sequential model. The model is also known as the waterfall or the software lifecycle. The principal stage of the model map into the fundamental development activity, requirement analysis and definition, system services, constraint and goals are established. Details are served as the system specification. System and software design partition and the requirement to either hardware or the software system established as an overall system architecture. Identify and describe the fundamental software system abstraction and their relationship. Implement implementation and unit testing. Software design is realized as the set of program or the program unit. Unit test is performed to verify each unit meet in specification. Integration and the system testing. Individual program unit or the program are integrated. Perform test to ensure that the requirement are met. Operation and maintenance. It is the longest life cycle phase. The system is installed and put into the practical use. Maintenance involved error correction and improving the implementation of the system unit, enhance the system service to meet the new requirement. The drawback of the waterfall model is the difficulty of accommodating a change after the process is underway. BCA fourth semester requirement definition, system and software design, implementation and unit testing, integration and system testing, operation and maintenance. In the principle, the result of each phase is one or more approved a document. The following phase should not start until the previous phase has finished. In practice, these stages overlap and feed information to each other during design. Problems with the requirement are identified during the coding. Design problems are found and so on. The software process is not simple linear model but involves a sequence iteration of the development activity because the cost of the producing and approved document iteration are costly and involve significant work. Therefore, after a small number of iteration, it is normal to treat the part of development such as specification and to continue the later development stage. Problems are left after a resolution ignored or are programmed around. The premature freezing of the requirement may means the system won't do what a user wants. It may also lead to the badly structured system waterfall model, inflexible partitioning of the project to the distinct state. It makes it difficult to respond to the changing customer requirement. Therefore, this model is only appropriable when the requirements are well understood. The prototyping paradigm offers a best approach when a customer defines a set of general activity for a software but does not identify detailed input processing or the output requirement. A developer may be unsure of the efficiency of an algorithm, the adaptability of an operating system. It begins with the user requirement gathering where a developer and the customer together define overall objective of the system, identify whatever requirement are known and outline the area where further definition is mandatory. Develop a quick design that focus on the input approaches and the output format that is visible to the customer user. It leads to the construction of the prototype that serves as a mechanism for identifying the software requirement. Prototype is evaluated by the customer users and refine the requirement for the software to be developed. The prototype serves as the first system where the user get a feel for actual system and developers get to build something immediately, build a revised mockup, listen to the customer test drive mockup. In this model, the key line is to define the rules of the game at the beginning. That is, customer and the developer must agree that the prototype is built to solve a mechanism for defining requirement is then discarded and actual software is engineered considering quality and maintainability. The prototype modern problem prototypes appear to be working version of the software, but all the software quality and long-term maintainability has not been considered. The final must be rebuilt implementation compromise for the quick working prototype. The RAD model, Rapid Application Development, is an incremental software development process with the extremely short development life cycle. It is the high-speed adaptation of linear sequential model in which a rapid development by using the component-based construction. RAD process enable a curate fully functional system within a very short time period. If the requirements are well understood and the project scope is constrained, user use primarily for the information system application. The RAD approach encompasses the following phases: business modeling. The information flow among the business function is model to ensure the following question: the information drives the business process. What is the information is generated, who generate it, where does the information go? Who process it? Data modeling. The information defined in the business modeling is redefined into the set of data object data needed to support the business. The characteristic attribute of each object are identified and relationship between this object is defined. Process modeling. The data object defined in the data modeling phase are transferred to achieve the information flow necessary to implement the business function. Process description are created for adding, modifying, deleting, or retrieving a data object. Application generation use of code generation technique, reuse of existing program component or create a reusable component. Automated tools are used to facilitate the construction of the software. Testing and the turnover. Since the RAD process emphasizes the reuse of many program components have already been tested that reduce the overall testing time. Testing of the new component, business model, data modeling, process modeling, application generation, testing and turnover, business modeling, data modeling, process modeling, application generation, testing and turnover, business modeling, data modeling, process modeling, application and generation testing and turnover. Drawbacks of RAD model: for large scalable project, RAD requires sufficient human resources to create the right number of RAD term. RAD requires developers and customers who are committed to the rapid fire activities are necessary to get the system complete in the much abbreviated time frame. In the lack of commitment from the either side of RAD project fail. If the system cannot be properly modularized, building a component necessary for the RAD will be the problematic. A RAD approach cannot be used for the high performance. RAD is not appropriate when the technical risks are high. Evolutionary software model process. The software system always evolves over the period of a time in course of the project due to change in the business and the product requirement. So the product a process irritation where the earlier states are revoked. The linear sequential model is designed for state or for the state line requirement. In essence, this waterfall approach assumes the complete system will be delivered after the linear sequence is completed. The prototyping model is designed to assist customer in the understanding a requirement. In general, it is not designed to deliver the production system. The evolutionary nature of the software is not considered in either case of this classic software engineering paradigm. Iteration can be applied to any generic process model. Two related approaches: incremental development model, spiral model. Incremental model, it combines the element of linear sequential model with the iterative philosophy of prototyping. It applies to the linear sequence in the staggered fashion, such as calendar time progresses, rather than deliver a system in as a single delivery. User requirements are prioritized in the high priority requirement, which are included in early increment. Each linear sequence produces a deliverable increment of the software, where the software flow for an increment can incorporate the prototyping paradigm. The first increment result in the core product, where the basic requirements are addressed, but many supplementary feature remains undelivered. After the development of a core product, here its evaluation of plan is developed for the next increment. Define outline requirement, assign a requirement to increment, design a system architecture, develop the system increment, validate increment, integrate increment, validate system, final system analysis, design, code, test, delivery of first increment, analysis, design, code, test, delivery of second increment, analysis, design, code, test, delivery of third increment, analysis, design, code, test, delivery of fourth incremental development advantage. Customer value can be delivered with each increments for the system functionality is available. All increment act as the prototype to help equally requirement for the later increment or lower the risk of overall project failure. Highest priority system solves tend to receive the most testing spiral model as purposed by the Bohem. It is the risk-driven approach to the software development that couples the iterative nature of prototyping with the control and the systematic aspect of the linear sequential model. It uses the prototyping as a risk reduction mechanism and retains the systematic stepwise approach of the waterfall model. Software is developed in a series of incremental release. The process is represented as a spiral rather than a sequence of activity with backtracking. Each loop is the spiral represent the phase of process. No fixed phase such as specification or design loops in the spiral are chosen. Risks are explicitly assessed and resolved throughout the process. Model is divided into the number of framework activity called the task region that contains customer communication tasks required to establish planning tasks required to define resources, timelessness, and other project related to information, risk analysis, tasks required to assist both technical and management risks, engineering tasks required to build one or more representation of the application, construction and release, tasks required to construct, test, install, and provide the user support, determine objective, alternative, and constraint, evaluate the alternative, identify resolve risk analysis, operational prototype, prototype 3, prototype 2, prototype 1, requirement plan, concept of operation, SW requirement, requirement validation, product design, design BNB, service acceptance test, integration test, unit test, code, detail design, develop, verify, next level product, next plan, next phase, spiral model sector objective setting, specific object for the phase are identified, alternative solution and its constraint, risk management, alternative solution are evaluated and potential project risks are assessed and the activity put in place to reduce the key risks by developing an appropriate prototype. Development and validation. A development model for system is chosen, which can be a generic model. Planning the project is reviewed in the next phase of the spiral model. As a model, spiral model can be viewed as the meta model sheet. It encompasses all the previously discussed model and uses the prototyping as a risk reduction mechanism. For example, single loop spiral actually represents waterfall model. The spiral model uses evolutionary approach. Iteration along with the spiral can be considered as a evolutionary level through the complete system is built. The spiral model enables the developer to understand and react the risks. Create the evolutionary model. The spiral model is suitable for the development of technically challenging software products that are prone to the several kind of risks. It could be used as effectively for the system enhancement and as for system development. Most life cycle model can be considered as a special case and spiral model. Component based development CBD model, component oriented technology provide the technical framework for component-based process model. It emphasizes the creation of classic that encapsulate the both data and the algorithm used to manipulate the data. Properly designed and implemented object-oriented classes are reusable across the different application. mm, Computer-based system architecture and advantage of CBD model, reusability of the software, reduction of the development cycle time, reduction of the project costs, increase the productivity, comparison, different cycle model summary. Software engineering is the discipline of the integrated process, method, and tools for development. Software process are activity involved in producing. A general activity are specification, design, and implementation. Generic process model describe the organization. Iterative process model describe the software process. Requirement engineering is the process of developing a software application. Design and implementation process transfer the specification. Validation involves checking that the system meet its specification and the user need. Evaluation is concerned with the modifying the system after it is in use. Spiral model use the prototyping as a risk reduction mechanism and retains the systematic stepwise approach of the waterfall model. आजको लागि सफ्टवेयर डेभलपमेन्ट प्रोसेस, सफ्टवेयर इन्जिनियरिङको यति छ। फेरि हामी अर्को भिडियोमा सुरु